Hello and welcome back. This is Dr. R.V. Argiddi from WT Solapur. I am going to focus on the topic from the topic function, which is from the subject discrete mathematical structures. Okay, in which we'll learn what is domain and what is range of the function. The learning outcome of this today's video, student will be able to identify or he will find what is domain and what is range of the function. The contents we are going to cover, first of all, we will define what is definition, then we will define what is domain, what is range of the function, and then we will focus on the examples on domain and range. The definition of the function can be defined in this way. Suppose there are say two sets, x set x and set y, and suppose there is a mapping or there is a relation f. Okay, f is denoted by relation f from set x to set y is called a function. Okay, for every x there should be unique y. Okay, unique y, then it is called as a function. Apart from that, this relation should satisfy the two conditions. After satisfying these two conditions, it can be called as a function. The first condition is that every x, means the elements of set x should be mapped or must be related to some elements of y which belongs to set y. Or in other words, it is called the domain of the function f must be equal to set x. It should not be equal to set a subset of x. Okay, we will focus or we will learn detail in the next slide what is domain. Now, what are the different terminologies? Second condition, uniqueness should be maintained. In the sense that every x should have mapped to unique value of y. It should not be mapped to two elements of y. One of the element of set x should be mapped to only one element of y, not more than one. So, uniqueness should be maintained. So, that is called as if suppose a relation satisfies these two conditions, then it is called as a function. Now, let us see what are the terminologies for the functions. Okay, function can be called as a mapping, or it can be called as a transformation or a correspondence. How it is denoted? It can be denoted by giving the name function f, and then we give the sets, that is set x and y. In between we have an arrow, okay, saying that x is mapped to y, or it can be mentioned in the third line like this, x mapped to y, and on this arrow we can give the name of the function. Okay, that can be used to express the function from set x to set y. Now, what is argument and what is image? Okay, f of x, we write generally f of x is equal to y, where x is called as a argument and y is called as the image of the argument. Under the function f. Now, let us see what is domain and the range of the function. Or instead of writing an ordered pair x y which belongs to f, okay, we can write y is equal to f of x, or f of x is equal to y, or call y as the value of the x, or call y as the image of the argument x. Okay. And domain of the function is denoted by d, capital D, and we mention the subscript to that domain as name of the function. Okay, is equal to maybe set x or maybe subset of x, and the range of the function is denoted by capital R, and subscript is given as the name of the function. Here it is f, R of f. It can be subset of y or it can be equal to y, and y is also called as the codomain of the function f. Now, let us see the first example on the domain and range of this function. Suppose there are two sets, set x is equal to say the elements 1, 5 p and jack, and y is equal to say 2, 5, 7 q and jill, and mapping or the function, it is denoted by f is equal to from set x, the first order pair is given. In an ordered pair, it is x y. The first element represents for x and second is representing for y. Means 1 belongs to set x and 2 belongs to set y. 5 belongs to set x and 7 belongs to set y, and p belongs to set x and q belongs to set y, and jack belongs to set x and q belongs to set y. So, this is how we mention the function. The same thing can be pictorially represented with this mapping, saying that 1 is mapped to 2, or 2 is the image of argument x, or 5. This 5 is not image of any element of x, okay, and 7 is the image of 5, or f of x is equal to f of 5 is equal to 7, or f of p is equal to q and f of jack is equal to jill. So, these are the mapping. Now, how to identify the domain? How to identify the domain and how to identify the range? Now, if you look at this particular mapping, okay, we have to consider the elements involved in a mapping from set x right down as a domain, and in a range the elements which are involved from set y in the mapping should be called as a range of the function f. Now, let us see what are the elements which are involved from the set x. See, the element set x is involved, from the set x 1 is involved, then element 5 is involved, means it is mapped to element y as 7, then p is involved in the mapping with q, and jack is involved in the mapping with jill. So, the domain of the function will be 1, 5, p and jack. These are the values for the domain, which is equal to, is it equal to set x? Yes, it is equal to set x, which is not subset of x. Okay, all the elements of x are involved, means this particular mapping, first condition it satisfies. Okay. And second condition of the mapping was whether every x has unique value of y. Yes, let us see. One is having only one value 2, it is not having second value of y. 5 is also having unique 7, p is involved with q only, and jack is involved with jill. Means uniqueness of y is also maintained over here. That is why this is called this mapping is called the function. Means domain of the function is equal to set x, and there is a unique y for every x. So, this is a function. Now, as I told you, domain is 1, 5, p and jack, and the range, what is range? Consider the elements from the set y which are involved in the mapping f. Now, which are the elements which are involved? 2 is involved with 1. Okay, 5 is not at all involved in any of the elements of x. Then 7 is there, and q is there, and jill is there. Means 2, 7, q and jill for the range of the function, and 1, 5, p and jack will be called as the domain of the function. Let us go to the next slide. It is mentioned over here. Domain of the function is equal to 1, 5, p and jack, which is equal to set x, and range of the function. Okay, that is domain of the function which f is equal to 2, 7, q and jill, which is not equal to y, but it is a subset of y. It is subset of y. So, this is first example, and consider the second example, and take a minute, okay, and find out what is domain and what is the range of the function g. Okay. Here set x is equal to a b c and set y is equal to 0 1, and the mapping is generated by g from x to y, which is given by 1 0 a 0 b 0 c 0 a 1 b 1 c 1. Take a minute and find out the answer. Now, find out the mapping. Okay, find out the from this relation, from this mapping, okay, which belongs to set x. A, b and c. A, b, c are the elements which involved in the mapping, and 0 and 1 are involved in from set y. Let us see what is the answer. Answer is domain of function g is equal to a b c, and the range of the function is nothing but 0 and 1. Means that from this particular mapping, okay, a 0, b 0, c 0, and then a 1, b 1 and c 1 means a b c are common. So, domain is a b c and range means 0 and 1 both are involved, means it is equal to set y. It is equal to set y and domain is equal to set x. Here domain is equal to set x. So, these are the so today what we have learned, what is function, then we have seen what is domain, what is the range, how function is denoted, and examples on domain and range. I hope you have understood these concepts, and we will see in the next video for new topic. And for today's video, we have referred these books. Thank you very much.